Good day and welcome to the HydraForce YouTube channel. I'm Jim Pytel and I'm here at the invitation of HydraForce to discuss pressure control using pressure relief valves. This presentation is intended to be part of an ongoing series on basic hydraulic system design and valve selection using HydraForce valves and products. Our objective in part 1 is to examine the purpose, function, and application of pressure relief valves in a hydraulic system. Additionally, we'll take a closer look at the performance characteristics of the HydraForce RV20 series of direct acting pressure relief valves and the HydraForce RV26 series of pilot-operated pressure relief valves. Imagine, if you will, the frustration of working on a system that regularly experiences one of the following undesirable events, presented in increasing order of severity. Repeatedly distorts, disfigures, dents, or otherwise damages a workpiece. Regularly breaks itself by bursting a hose, busting an O-ring, or rupturing an actuator. Or worse yet, suddenly blowing up in your face. Pressure relief valves ideally prevent these types of events. We'll examine applications of pressure relief valves and compare and contrast the different types of pressure relief valves. Pressure relief valves are a subset of the larger pressure control family of valves, which, as the name implies, control pressure in a hydraulic system. The larger pressure control valve family includes, but is not limited to, valves like sequence valves, counterbalance valves, hydraulic torque dividers like the HydraForce HTD 10-40, and pressure reducing valves. On a very simplistic level, pressure is synonymous with force, and by controlling pressure, we control the force of our system to keep things from breaking. This being said, pressure and flow are a related phenomenon, and pressure control valves can also be used to indirectly control flow rate and actuator speed. Because fluid always flows from a region of higher total energy, i.e. a region of high pressure, to a region of lower total energy, i.e. a region of lower pressure. Additionally, pilot-operated pressure control valves can perform specific functions based on pressure conditions in different parts of the circuit. This is useful in applications such as sequencing actuators, charging accumulators, load sensing controls, pressure compensation, and flow sharing applications. Pressure relief valves, the topic of this particular presentation, are a type of normally closed pressure control valve that bypass flow, typically, but not always, to the reservoir or tank to limit pressure in a circuit. In summary, pressure relief valves protect system components from overpressure conditions by providing a relief path for flow when pressure gets too high. Pressure relief valves can be found at several points in a hydraulic system, each specialized to perform a specific function. Examples of general pressure relief valve applications include main pressure relief, workport pressure relief, crossover pressure relief, thermal pressure relief, and pilot system pressure relief. Main pressure relief. The most fundamental application of pressure relief valves are the main relief valves installed at the manifold inlet, which limits the maximum pressure of the larger system to protect the pump and the entire circuit. If a valve is moved to a closed position, an actuator reaches the limits of travel, or if flow is otherwise blocked, the positive displacement pump continues to rotate, flow has no outlet, and pressure rises rapidly, within milliseconds. Flow will find a path, be it through a ruptured hose, a fitting, valve, or broken seal. Sensing an impending overpressure condition at its inlet, the main pressure relief valve opens and diverts flow to the reservoir, thus avoiding disaster. Workport pressure relief. Pressure relief valves can also be found at other points in a hydraulic system. For example, consider a pressure relief valve installed on one or both of the workports of an actuator. In this application, the workport pressure relief limits the force of that actuator. As an additional safeguard, an integrated check valve on the workport pressure relief valve allows free flow to prevent cavitation. In the case of an overrunning or negative load, the check valve allows oil to flow into the side of the actuator that is creating a vacuum. This vacuum can create a situation where cavitation can occur and cause premature failure of the actuator. Crossover pressure relief. Pressure relief valves can also be employed between actuator workports. Consider a crossport pressure relief valve used to cushion the stop of a unidirectional hydraulic motor. In this application, the crossport pressure relief valve opens when pressure rises above a preset value and ports fluid back to the inlet or across the workports. When the control valve stops flow to the actuator, the inertia of the rotor and driven load continues to rotate and the motor acts as a pump. The closed position of a directional control valve would give the pumped oil nowhere to go, causing a dramatic pressure spike. The faster the motor and the heavier the driven load, the greater the pressure spike. This damages the motor, the directional control valve, the hoses, and fittings. As if that wasn't bad enough, the motor inlet experiences vacuum conditions and can cavitate just like a starved pump. A crossover pressure relief valve, however, opens to allow flow back into the motor inlet, alleviating both adverse conditions, the pressure spike on the outlet and the cavitation on the inlet. The direct-acting bias spring also absorbs and dissipates energy, slowing the motor more smoothly. Bidirectional crossover pressure relief valves, like the HydraForce CR28 series of valves, consist of two crossover pressure relief valves in a reverse parallel, or the HydraForce CR38 series, consisting of a single bidirectional crossover pressure relief valve, can be employed in bidirectional crossover relief applications. Connected in this fashion, these crossover pressure relief valves would serve to cushion the stop of a hydraulic motor when operated in either direction. You'll note in crossover pressure relief applications, relief flow is not diverted to the tank, but rather from one work port to another. Thermal pressure relief. A rather simple application of pressure relief valves can also be found in thermal pressure relief. Any fluid subjected to increased heat can expand. If trapped in an actuator with load holding or zero leak valves, the increased pressure can damage seals, fittings, valves, or conductors. A thermal pressure relief valve isn't intended to divert a significant quantity of flow, but rather act as a momentary pressure escape in the event of a thermally induced pressure rise. Pilot pressure relief. Finally, pressure relief valves can also be employed in pilot systems used to control the primary hydraulic system. Similar to applications in primary circuits, pressure relief valves in pilot systems can be used to limit pressure spikes in pilot circuits and load sensing circuits, or to limit pressure as a means of pilot control in logic circuits. Let's take a look at the basic operational principle and performance characteristics of pressure relief valves. In its most simple form, a pressure relief valve is a normally closed valve that opens only when pressure exceeds a certain preset value. A fixed pressure relief valve is one in which this value is preset at the factory through spring choice and is not user adjustable. An adjustable pressure relief valve, in contrast, is one in which a user can change the pressure setting, typically via means of an adjustment screw that changes the spring preload. Pressure relief valves are generally classified as either direct acting or pilot operated. We'll examine other pressure relief valves and discuss special applications in later presentations after we compare and contrast these two different methods of operation and their performance characteristics. The HydraForce RV20 series of pressure relief valves are direct-acting pressure relief valves. A direct-acting pressure relief valve, as the name implies, is a single-stage valve in which fluid pressure directly acts upon the main poppet that serves to close off the relief passage. When pressure-induced force exceeds the force of the spring used to seat the poppet opens. The principal advantage of direct-acting pressure relief valves is that they are simple in both construction and operation. Being single-stage devices, direct-acting pressure relief valves are known for their extremely fast response times. This being said, direct-acting pressure relief valves exhibit certain performance characteristics that must be accounted for in system design. We'll examine these characteristics in a moment. The HydraForce RV26 series of pressure relief valves, in contrast, are pilot-operated or two-stage pressure relief valves. A pilot-operated pressure relief valve is one in which a pilot stage directs the operation of the primary stage. When pressure-induced force on the pilot piston exceeds the force of the small spring, the pilot piston opens and upsets the balance of the primary poppet, thereby opening the main relief passage. Pilot-operated pressure relief valves are quieter, more stable, and intended to handle larger flow rates than a direct-acting pressure relief valve. This being said, pilot-operated pressure relief valves are two-stage devices and exhibit certain performance characteristics that must be accounted for in system design. Let's compare and contrast these two styles of pressure relief valves, direct-acting and pilot-operated, in terms of some common performance characteristics, specifically overshoot, pressure rise or pressure override, cracking pressure, reseat pressure, and hysteresis. Overshoot. In a perfect world, all pressure relief valves would have a clear and defined set pressure, above which the pressure relief valve instantly and fully opens, and a reseat value below which the pressure relief valve instantly and fully reseats. In the real world, we might expect pressure to overshoot the initial set value, as these plots of relief performance as a function of time demonstrate. There is a degree of overshoot for the direct-acting pressure relief valve. However, due to the fast-acting nature of the valve, not by much. Pilot-operated pressure relief valves, in contrast, are two-stage devices and may exhibit a slight time delay in the initial response, allowing for a more significant pressure overshoot. This being said, notice how the pilot-operated pressure relief valve's response effectively settles at a constant value in a shorter amount of time, whereas the direct-acting pressure relief valve exhibits less stability over time. This is to imply that once the brief overshoot accounting for the delayed response of the two-stage pilot-operated pressure relief valve is passed, such a device offers more precise control of pressure. In keeping with this theme, pilot-operated pressure relief valves offer other related advantages. The smaller pilot spring in a pilot-operated pressure relief valve allows a greater resolution of setting values than would a larger spring in a direct-acting pressure relief valve. And, given the pilot piston's only function is to indirectly open the main poppet, pilot-operated pressure relief valves allow for larger flow ratings with less unfavorable effects. Pressure rise or override. Pressure rise or pressure override is the characteristic difference in pressure across the full flow range of the valve. Pilot-operated pressure relief valves generally exhibit less pressure rise, and this can be desirable in some situations. It is important to understand there will always be a trade-off between speed and stability, and this is the most important performance consideration when comparing direct-acting and pilot-operated pressure relief valves. Cracking pressure. Cracking pressure is the pressure which the valve initially cracks open. Most manufacturers will further define this as the gauge pressure evident at a stated small flow rate, which is dependent upon the size and operating characteristics of the valve. Reseat pressure. Reseat pressure is the pressure at which the valve changes from an open state to a closed state. This performance characteristic is typically defined as a percentage of the cracking pressure. The span between the cracking and reseat pressures defines the hysteresis of the valve. A pilot-operated pressure relief valve, because of its precision, might exhibit less hysteresis than would a direct-acting pressure relief valve. In summary, direct-acting and pilot-operated pressure relief valves both accomplish the same task, i.e. limiting maximum pressure. However, they do so using different methods. These different methods lend themselves to different performance characteristics. Direct-acting pressure relief valves are simple, robust, single-stage, low-leakage elements that offer faster response, exhibit less overshoot, and are more tolerant to contamination. This being said, direct-acting pressure relief valves exhibit a higher pressure rise as the relief flow increases, exhibit a larger hysteresis or span between cracking and reseat pressure, and are intended for lower flow applications. In contrast, pilot-operated pressure relief valves are more sophisticated, i.e. more complicated, two-stage devices that are more precise and stable. They exhibit less override, exhibit a smaller hysteresis or span between cracking and reseat pressure, and are designed to handle larger flow rates. This being said, because of their inherent more complicated nature, pilot-operated pressure relief valves have a slower initial response and may exhibit a brief initial overshoot. Additionally, they're more susceptible to contamination events because of the smaller clearances inside the pilot passages. It should be noted that HydraForce 26 style pressure relief valves have a patented self-flushing feature to prevent contamination. All these performance characteristics are critical to valve selection suitability for a specific application. Alright, this concludes this brief presentation discussing basic pressure control using direct-acting and pilot-operated pressure relief valves. If you're interested in obtaining more information about the HydraForce RB20 series of direct-acting pressure relief valves, or the HydraForce RB26 series of pilot-operated pressure relief valves, or speaking with HydraForce about incorporating other HydraForce products in your design, feel free to visit the HydraForce website at www.hydraforce.com. Power forward with HydraForce.